Hi everyone! Today we are going to talk about our TC117 and TC217 Advance tabs. These tabs are designed for universal use, they fit into inch collets, and we are convinced that they will help you to streamline your production to save costs. In this video, we show you how the coatings of the TC117, TC217 tabs compare to the industry standard. We demonstrate how the tools work in different materials, and we give you a quick overview of our large offering. But before we go into the details, let's start with a quick rundown of the Walter product lines. There are three designations to Walter product technology: Perform, Advance and Supreme. Perform tools provide an economical solution with a focus on price. These are high-quality tools which are focusing on the essentials. Advanced tools are efficiently balanced between price and performance. They have advanced technological features to improve reliability and productivity. The Supreme designation indicates the highest level of technology and performance available. These tools are designed to maximize productivity. So when we talk about the TC117, TC217 Advance tabs, we are talking about tabs that have a great price-performance ratio. The TC117 is a spiral flute tab for blind hole machining, and the TC217 has a spiral point for through holes. That's enough talk, let's make some chips. We are going to compare the chip formation of an ordinary tin coating with the advanced grades of the TC117, TC217 tabs. And this we do on a lathe, because here we can see the chip formation perfectly. We have a 4140 material on the machine, and we are going to thread blind holes. Let's start with the TC117 and the steam-tempered grade WY80FC. Steam tempering is not a coating, it is a surface treatment where an iron oxide layer is created on the surface of the tool. And let's see how that works out. The chips are very tightly, and the more tightly the chip is curled, the lower the risk of bird nests and therefore the better the process reliability. The downside of the steam tempering treatment is that it is not a coating. So it lacks the wear resistance and the temperature resistance of a real coating, and therefore the tool life is lower and you have to run these tools at a lower cutting speed. Let's now have a look at the TC117 with its advanced titanium aluminum nitride grade WY80RG. The chips are almost as tight as with the steam tempered tool. So the process reliability is also on a great level. And for most of the applications, the titanium aluminum nitride grade WY80RG is the first choice. Now we switch to an ordinary tin-coated tab. And here's the result. The chips are quite loose, and loose chips increase the risk of bird nests. So let's recap. The titanium aluminum nitride grade WY80RG gives you a better process reliability than an ordinary tin or TICN coating. But the best chip formation you get with the steam-tempered grade WY80FC. Here's an example that shows the difference in reliability. With the tin-coated tab, we have a bird nest after 10 threads. And the tool with titanium aluminum nitride coating runs without issues. Some general advice. If you struggle with bird nests, use slotted collets with internal coolant. The coolant flow will prevent the chips from sticking to the tool. In addition, reverse with double the RPM so that the centrifugal force helps to remove the chips. Or think about using form tabs, which are great for stringy materials like soft structural steels. Alright, so much to the reliability. Let's now have a look at the application range of the TC117, TC217 tabs. For this, we switch to a machining center. We have prepared different materials to illustrate the capabilities of our tabs. It won't surprise you that we have picked common materials like 1045, 4140, 304 stainless, brittle gray cast iron, stringy 6060 aluminum, and brass. It was our target to develop a universal tool that not only works in all kinds of materials, but has a great performance across the board. So here's the result of our benchmark test for the TC117 in 4140 steel with 300 HP. We have tested quite a few competitors, and in steel there is no substantial difference. But if we look at the benchmark test for 316 stainless, then the picture changes. While the performance of most of the competitors drops, the performance of the TC117 remains on a great level. It is easy to make a tool that performs great in steel, but it is hard to make a tool that performs great in both steel and stainless steel, because these materials have very different characteristics. And the TC117, TC217 tabs not only work great in common stainless steels like 304 or 316 stainless, they also can cover demanding materials like duplex stainless steels. Here we machine a 4462 grade F51. So you really can cover a wide range of different materials with these tabs. As for the thread depth, the TC117 is designed to reach a depth of 2.5 times the diameter. If you need to go deeper than that, you can switch to Supreme tabs. The TC217 can machine threads with a length of 3 times the diameter. And this we will check out with an example in the dimension 1/4 UNC. Here we have a 304 stainless and the thickness of the blade is 3.3 times the diameter. We run the tool with 30 SFM, which is twice as high as the recommendation. So let's see what happens. The spiral point of the TC217 curls the chips tightly so that chip evacuation is no problem. And therefore, we reach depth without any issues. Practical advice: when machining deep through holes, make sure to have a good coolant flow. In our example, we used a slotted collet with internal coolant to support the chip evacuation. Last but not least, let's have a quick look at the offering. When we are talking about a large offering, this is it. We start at a tiny dimension 164 UNC and we go all the way up to 1.5, 6 UNC, with lots of intermediate sizes. The same is valid for the UNF range, which starts at a dimension 0.80. In addition, we cover UN8 pitch threads, UNS, STI UNC, STI UNF, as well as metric threads. The TC117, TC217 tabs are made with an inch shank and thin length, so they fit into your inch collet, but compared to ANSI tabs, they have additional length. And this extra length will help you to machine threads that are hard to reach. As for the tolerances, a neat feature of the TC117, TC217 tabs is that you can cover 2B and 3B tolerances with the same tab. This really helps you to reduce inventory and simplify handling. The tabs are also available in H7 and H11 oversized tolerances, so you can compensate for coatings and heat treatment distortion. The TC117 is available with semi-bottoming and bottoming chamfer, so you can reach close to the bottom of the hole. If you need to get closer to the bottom than that, well, then you need to switch to a thread node. So long story short, the TC117, TC217 Advance tabs offer great reliability and great performance in a wide range of different materials. Due to the large offering, you can use them across the board. We are therefore convinced that these tabs will help you to streamline your production to save costs. Get your test tools and see for yourself. Thanks for watching.